Hello! Today in our lesson, we will be writing a fractional expression as a product. Let's write an example. A is divided by B. This is a fractional expression. We need to write it as a product. These steps are done so that you can write the answer in different forms. Equals A divided by B. Let's use it. Our definition. If we see the expression 1 divided by a to the power of n, then this expression equals a to the power of n. So, using our definition, we move the variable b from the denominator to the numerator. As a result, we get a multiplied by b to the power of minus 1. Don't forget to write the power of minus 1. The thing is, b has a power of 1. But we can leave out the power of 1 when writing it. But the power of minus 1 must always be written. Why do we write it in different forms? The thing is, when you solve a problem, you get a certain answer. But this answer might be different from the one given in the resources. That's why you need to be able to write a fractional expression as a product, or a product as a fractional ratio. And then we need to apply our definition of a negative exponent. But in the denominator, it isn't always a positive number that's written. There can also be a negative number in the denominator. But this doesn't change the algorithm for applying our definition. Let's write down the following expression together. If I write the fraction 2 divided by c cubed, that's a fraction, but I need to write it as a product. So I write 2c to the power of 3. You've probably already noticed that when we move a variable or an expression from the denominator to the numerator, the exponent changes to the opposite with the opposite sign. Or, conversely, if we move a variable with a negative exponent into the numerator, then the sign of the exponent changes. Why into the numerator? Well, the thing is, in the denominator it remains as 1. We can solve this example in another way. I'll write 2 divided by and to c to the power of minus 3. We apply our definition. As a result, we get 1 divided by c to the power of 3. Now let's write 2 divided by 1, and in the denominator, c to the power of 3. And then, according to the rule for dividing by a fractional number, we need to flip it. And as a result, we get 2 times c to the power of 3 divided by 1. And in the answer, we write 2. c to the power of 3. As you can see, we have the same answer. Next task. X squared divided by 3. Y to the power of 3. In the numerator, we leave the variable x squared. But from the denominator, we move it to the numerator. Don't forget that the exponent of the number also changes. The number 3 has an exponent of 1, so I write 3 to the power of minus 1 and y to the power of minus 3. Also, don't forget that we apply our definition to numerical expressions as well. As a result, we get 3 to the power of minus 1, x squared, y to the power of minus 3. Notice that I have written the final answer. The number comes first. Then the variables are written in alphabetical order. And let's solve another example. We solved the second example in 2 ways. The third example and the fourth example. A squared, b squared, divided by a to the power of minus 2, b to the power of minus 2. We will use our rule. What do we get as a result? When we move a to the power of minus 2 from the denominator to the numerator, then, as a result, I end up with a squared. A squared was in the numerator, and I brought it up from the denominator to the numerator. So, in the end, it's a squared multiplied by a squared. B squared multiplied by b, also squared. But in this case, we can apply the properties. As a result, we get a to the power of 4 multiplied by b to the power of 4. I want to draw your attention to the fact that we can also solve this example in another way, not by using the definition, but by applying the properties. What do I want to highlight? In this case, I can use the properties. For this, I subtract the exponents. A to the power of 2 minus minus 2. And I will use the same algorithm for the variable b. B to the power of 2 minus minus 2. What do we get as a result? A to the power of 2 minus 2 is 4, and b to the power of 4. As you can see, the answer is the same. In the next lesson, we will continue solving examples where we will use expression transformation. That's all for today. Goodbye.